Prologue. Commencement Ceremony, Mount San Antonio College, June 1990. The conflict between science and spirituality primarily stems from a linguistic confusion over what the term matter means and what it ultimately implies. This first came into sharp focus for me when I was attending the annual graduation ceremonies at Mount San Antonio College in June of 1990. I had only been hired the year before, so I was relatively new to the proceedings. As I was getting ready to walk in with my philosophy cohorts, dressed as we were in our long robes and mortarboards, another young professor from another department came up to me in a visibly irritated mood. After we exchanged pleasantries, he pulled out an issue of Plato's Cave, the new journal that I founded along with some students a few months prior. He queried, "Why would you allow this blasphemous claptrap to be published?" Before I could respond, he proceeded to rip the small magazine to pieces in front of me and threw it on the floor and walked away in disgust. A mathematician friend of mine witnessed the spectacle and asked, "What was that all about?" I responded that I didn't exactly know, but I mentioned that it concerned a recent issue of Plato's Cave, which contained an interview with Patricia Churchland, an eminent professor of philosophy at UCSD, who had more or less invented the new field of neurophilosophy, where ancient questions are examined in light of the latest discoveries in physics and neuroscience. The title of the piece was "The Neural Basis of Consciousness, a Glorious Piece of Meat, and the Dalai Lama." One of my star students, Meredith Doran, who is now a professor of French literature at Penn State, had conducted the interview, and I thought she had done a superb job in capturing the ins and outs of Professor Churchland's scientific view of how philosophy should be conducted in the future. Right then, another professor chimed in and said, "Oh, Dave, that guy who just verbally assaulted you is a fundamentalist Christian, and he thinks your publication contradicts the Bible and insults his religion." A few other colleagues also confirmed the same, and it became clearer to me why he would be upset by Churchland's advocacy of eliminative materialism. Yet, as I pondered over this episode, I couldn't help but wonder why certain religious persuasions are so troubled by science's reduction of man to mere material, given that matter itself was and is as mysterious and as glorious as anything conjured up in our spiritual imaginations. Before we tackle what matter is, and why an updated definition of what it portends can radically upend the persistent and pernicious dualism driving much of our religious resistance to science and its naturalistic underpinnings, I would like to indulge the listener in a thought experiment. A dialogue in Sachkhand. Clearly, the following is a metaphor pushed to its hyperbolic extreme, but I think it drives home an often overlooked point. Imagine finding yourself in a transcendental realm of bliss, and that within this ultimate region, you and your companion strike up a conversation, soul to soul. You inquire, "What are we made of?" And one of your blissful friends replies, "Light, of course. We are beings of light, and that is our core constituent." How would you, hypothetically, feel if someone did indeed inform you that you were a body of pure, unalloyed light? I have posed this question to both undergraduate and graduate students at various colleges and universities I have taught throughout my career, and invariably I get the same response. Almost in unison, they said they would feel exhilarated and boundless and happy. The idea that we are light gives us a deep sense of liberation. However, let's descend back to terra firma and ask a different question. Now, when we are in the here and now, a philosopher or a friend tells us that we are just material and just the body. Or, when the Nobel Prize winner, the late Francis Crick, says that consciousness is just a bundle of neurons. Or when Patricia Churchland indicates we are just 3 pounds of meat. How do we feel then? In sum, how do we feel when we are told that we are just this stuff, just this body, just the recomposition of this world? For most of my students, there is a certain sense of deflation, a depression, a grayness or flatness, as if the air had been sucked out of a balloon. Unlike the notion that we are beings of light, the idea that we are just the body gives us a deep sense of entrapment. One could, of course, argue at this juncture that this very feeling is why dualism arose in the first place. We feel that we are more than our bodies and, as such, that there is something transcendent in us. This primordial distinction, which appears to have arisen in most Homo sapiens, has no doubt influenced much of our religious and philosophical outlook. But I think the real confusion is in our fundamentally distorted understanding of what matter actually is. We tend to think that matter and spirit are opposites, and that focusing on one discounts the other, and vice versa. Yet, the real problem may be linguistic and not existential. In other words, it may be the outdated definitions and mythological remnants inherent in those definitions that have caused us so much unnecessary confusion. In order to make this point crystal clear, we will need to take a tour of matter and find out why it is so much more than gray and flat. What's the matter? Although the origin of the word matter, derived from mater, is of relatively recent origin, it is intriguing to note that it appears to have been derived from the word mother, which in light of this article is revealing indeed. One can start from any object to get a glimpse into what matter may be. So for our example, let's use a book. On my desk right now, I have a copy of the annotated edition of Charles Darwin's famous On the Origin of Species, published by the Belknap Press of Harvard University Press, which contains a complete facsimile of Darwin's 1859 first edition. In examining the book, we not only discover a certain hardback binding, a nicely designed dust jacket, but 537 pages filled with small print. However, if we look at just one of the pages within this book, we soon realize that it is made of a fine quality paper, which undoubtedly was derived from some dead tree for the purpose of utilizing pulp. But what is a tree? A simple definition from a dictionary might explain it thus: a plant having a permanently woody main stem or trunk, ordinarily growing to a considerable height, and usually developing branches at some distance from the ground. Yet, if we probe further, we discover that such a plant is made up of much smaller constituent parts, such as millions of cells, which in themselves are made up of even smaller bits called molecules, which in turn are comprised of billions, nay trillions of atoms. Indeed, every physical composition on planet Earth is essentially the reconfiguration of atoms. Now the question, what is an atom, will give us a deeper insight into what matter actually is. The term atom was first coined by Democritus, influenced no doubt by his teacher Leucippus, who argued that things are made up of indivisible particles which cannot be cut further. By the turn of the 20th century, this view became modified when Max Planck and others realized that atoms contained smaller bits, such as a nucleus and an electron, and those, in turn, contained smaller units still, including photons, quarks, and so on. Richard Feynman, the famous physicist and architect behind quantum electrodynamics, QED, once quipped that if he had to reduce all of human knowledge into one intelligible sentence, he would write, "Things are made of littler things that jiggle." This is a profound understanding of material structure, and not merely a humorous slogan, as Feynman is getting right to the heart of the issue. Matter isn't just one thing, it is rather a scaffolding project of many layers, each of which reveals a different aspect of what matter can do under differing circumstances. For instance, if you are sailing on a 36-foot boat in the Pacific Ocean, there are so many things occurring at once: the blue sky, the luminous sun overhead, the gathering clouds, the increasing onshore winds, the 2 to 3 foot waves, the innumerable forms of organic life lying just below the water's surface, not to mention the navigating humans on the boat, attempting to steer and checking the compass and the GPS device in the cockpit, and all of these things are made of atoms. Reconfigure atoms in a certain way, and you get iron. Reconfigure another way, and you get the Taj Mahal. Reconfigure it still more, and you have Mount Everest. And reconfigure those same units, and you get millions of different species trying their best to adapt to a whole ecosystem which itself is a larger network of reconfigured atoms. And even the nucleus itself is, contrary to what Leucippus and Democritus opined some 2,600 years ago, divisible. Depending on the element, atoms come in different weights, depending on the number of protons within the nucleus and the number of electrons manifesting outside its chambers. Yet, even when we get to the very core of matter, we find yet another layer, and our understanding of what is actually going on turns indeterminate. As Sir Arthur Eddington once stated concerning the strange underpinnings inherent in quantum theory, something unknown is doing what we don't know. The latest theoretical conjectures concerning the basis of matter has more or less coalesced around the four fundamental forces in nature. 1. Gravity. 2. Electromagnetism. 3. Strong nuclear force. And 4. Weak nuclear force. Einstein's general theory of relativity is a radical explanation of gravity, whereas quantum mechanics has provided a remarkably accurate theory regarding electromagnetism, with strong and weak nuclear forces being also understood within its fold. However, scientists are troubled that general relativity and quantum theory do not mesh together, since one is classical and determinate, whereas the other is revolutionary and indeterminate, and being at odds with one another, they together do not provide us with a grand unified theory, GUT, or a theory of everything, TOE. Thus, for decades, there has been a quest for a more fundamental theory which can reconcile the world of quanta with the world of gravitons. The most viable candidate so far has been a reworking of string theory, which has evolved into a nested series of mathematical models, most popularly known as M-theory. As Stephen Hawking explains in his latest book, The Grand Design, M-theory is not a theory in the usual sense. It is a whole family of different theories. Ours is not the only universe. Instead, M-theory predicts that a great many universes were created out of nothing. But even here, the notion of nothing is itself caught in an epistemological confusion, since the very word nothing is literally nonsensical in this context, and as such is merely a placeholder for the breakdown of both our physics and our language. Most problematic for physicists is the upsetting discovery that pure and unadulterated objectivity breaks down at the quanta level, where Heisenberg's uncertainty principle serves as a sort of information cul-de-sac. Yes, you may know relatively the momentum of a single particle, but at the expense of not knowing its position, and vice versa. The absolute certainty that was bubbling forth since Newton's day as the hallmark of real science got obliterated when it was realized that chance was at the heart of nature. This is why Einstein wrote to his Max Born that he didn't study physics to find out that God plays dice. But in light of M-theory and the multiverse hypothesis, not only does God, and God here is, of course, merely a metaphorical way of saying ultimate nature or reality, play dice, but he or she does so in the dark countless times. Thus, the laws of physics in this universe could be quite different in a divergent universe, and given that M-theory implies a vast multiplicity of universes, it is odds and not necessarily design, which gives rise to the peculiar circumstances of our present astronomical reflections. As Niels Bohr, one of the early pioneers in quantum mechanics, warned, those who are not shocked when they first come across quantum mechanics cannot possibly have understood it. Bohr became the champion of the single most popular philosophic interpretation of the new physics, which would later be known as the Copenhagen interpretation because of the location of his institute. In many ways, Bohr's reasoning is akin to what we find in Plato's allegory of the cave, as found in his Republic, but with one very telling caveat. In Plato's story, we learn that prisoners shackled in the cave cannot actually see the light itself that is casting the varying shadows on the wall, and only later when unhinged can they progress from the rudimentary impressions to clearer shapes and outlines until the full luminosity of the light explains more fully how all these images were generated. In the quantum mechanical world, we are in a similar position, since we cannot actually know both the position and the momentum of any single electron, but only its probabilities, and even then, how we measure such an outcome predetermines its wave or particle manifestation. What the electron is really doing, nobody knows. Apparently, nobody can know what a single bit of matter is ultimately doing, since even that definition of bit of matter is itself a construct, a theoretical map in order to make sense out of one aspect of what appears at such minute levels of matter. What we get when we penetrate the subatomic realm isn't, to quote Kant, the thing in itself, but only what appears visible to our intervening devices. And since we cannot intrude into that realm without some type of instrument, even a single photon cascading off an electron causes a disruption of the assumed virgin state. We don't unlock nature pure and pristine, but as nature reacts to our measuring devices. In other words, we cannot unlock nature as nature, or electron as electron, or matter as matter, since we are invariably altering what we are examining. We might occasionally acknowledge this interference even at the macroscopic level. Sociologists and psychologists are well versed in interpreters' biases in grappling with raw data. But at the quantum level it looms so large and is so evidential that its impact cannot at any instance be ignored. Heisenberg's principle of uncertainty isn't merely a temporary limit to man's knowledge, according to Bohr, but a fundamental statement about what that knowledge is. It is for this reason that Plato's allegory is instructive, since we are not in the position of the narrator to look objectively upon the cave from the outside and the inside simultaneously. Rather, we are the prisoners in the cave, and only from that position can we both induce and deduce what may or may not be ultimately real, but in so doing we are still at the Kantian level of phenomena. What quantum mechanics revealed was precisely this epistemological limit, and how it plays out in trying to form a picture about reality. Reality we can never know, since that very concept is itself a fiction, which implies that we can somehow act as an objective narrator to the entire cosmos, with a 360-degree purview and a level of certainty which implies that we are impartial witnesses to a play with a beginning, middle, and an end. No, we are literally like the prisoners in Plato's allegory of the cave, limited by our very existence in what we can and cannot know. For Bohr, this wasn't merely a philosophical extension of his Kierkegaardian leanings, but the very result of what quantum mechanics revealed about our ability to come to grips with nature and how it responds to our introspections. As Bohr put it, it is wrong to think that the task of physics is to find out how nature is. Physics concerns what we say about nature. Or, as Bohr himself discovered, for a parallel to the lesson of atomic theory regarding the limited applicability of such customary idealizations, we must in fact turn to quite other branches of science, such as psychology, or even to that kind of epistemological problems with which already thinkers like Buddha and Lao Tzu have been confronted, when trying to harmonize our position as spectators and actors in the great drama of existence. Everything we call real is made of things that cannot be regarded as real. It is little wonder, therefore, that so many eminent scientists have had such ambivalent reactions and feelings to the implications of quantum mechanics. This is epitomized by a close reading of the following quotes garnered from the Quantum World website. Quantum mechanics is magic. Daniel Greenberger. Those who are not shocked when they first come across quantum theory cannot possibly have understood it. Niels Bohr. If you are not completely confused by quantum mechanics, you do not understand it. John Wheeler. It is safe to say that nobody understands quantum mechanics. Richard Feynman. If quantum theory is correct, it signifies the end of physics as a science. Albert Einstein. I do not like quantum mechanics, and I am sorry I ever had anything to do with it. Erwin Schrödinger. Quantum mechanics makes absolutely no sense. Roger Penrose. Hence, when we look at the very essence of matter, we discover that it has no such essence, at least not something that can be related to our common sense notions of the world. In fact, our very common sense breaks down when we examine the rudimentary basis of matter itself. Our evolution has bounded what we can and cannot know about the world around us. Because of this, our brains are not well adapted to understand either the very large or the very small. We are quite literally middling creatures that have been shaped for eons of time to survive in eco-niches where our food and prey are accessible to our 5 apertures. What this means, of course, is that whenever we venture beyond our Middle Earth by extending our senses to the very large or very small, we have to acclimate ourselves anew. The history of science is a record of how man achieved such acclamations and how, in turn, such new insights transformed his understanding of how the universe actually works. Whether it was Galileo's telescope seeing a pockmarked moon versus a polished lunar surface, or Copernicus' mathematical equations indicating a solar-based orbital system versus an Earth-centered one, in each case, sensory or mental breakthroughs led to revolutions in scientific thought. It may be no exaggeration to say that whenever man has altered his bodily or cranial limits, he has extended his world, a world which is forever linked to the limitations of what his senses can and cannot reveal. To say that neurology is ontology is merely to state the obvious. But what sometimes gets lost in such cliches is that man's brain state is never static, and thus his world is never the same as well. Change the neural apparatus and one transforms the universe. Not necessarily because the brain creates such realities, but rather because the limitations of one's cranial capacities predetermines what is accessible or knowable about any given aspect of reality. Change those neural coordinates, and thereby change one's intellectual map. All of this is a necessary preface to understand why the human mind has an almost innate difficulty in understanding quantum theory, a theory which takes into account things so infinitesimally tiny that even our best analogies freeze our minds in a state of wonder. Ludwig Wittgenstein gives us a fruitful glimpse of just how contradictory quantum physics can be, and why it demonstrates prima facie its almost inherent illogical nature. Writing several years before Werner Heisenberg's Nobel Prize-winning discovery of the uncertainty relations in the subatomic realm, Wittgenstein states in his famous Tractatus Logico-Philosophicus, "For two colors, e.g., to be at one place in the visual field is impossible, logically impossible, for it is excluded by the logical structure of color." Let us consider how this contradiction presents itself in physics, somewhat as follows. That a particle cannot at the same time have two velocities, i.e. that at the same time it cannot be in two places, i.e. that particles in different places at the same time cannot be identical. It is clear that the logical product of two elementary propositions can neither be a tautology nor a contradiction. The assertion that a point in the visual field has two different colors at the same time is a contradiction. Today, of course, quantum physicists state the opposite of Wittgenstein's logical necessity about the behavior of matter, and point out that indeed a particle can be in two places at the same time, even if that space and time is limited in its regional and temporal import. What Wittgenstein captured, quite unwittingly since his Tractatus dates from the latter part of the First World War, was how a rational logical mind would be upended by the implications of quantum theory. Moreover, he provides us with a framework for why it may be so difficult for many of us to actually get quantum theory. As Richard Feynman, the well-known architect behind quantum electrodynamics, QED, once quipped, "I think I can safely say that nobody understands quantum mechanics." Therefore, a very strong argument can be made that the real problem with materialism, the idea that everything that arises is nothing but permutations of matter, isn't that it is the exact opposite of spirit, or that it somehow diminishes human consciousness, but rather that we do not properly appreciate what the word actually means and what it entails. To say something is just matter is akin to saying something is just light, which matter, by the way, also contains. Even when intertheoretic reductionisms hold true, there is no just about it, since the very phenomena under inspection doesn't lose its mystery by being contextually or algorithmically comprehended. If someone says that the Atlantic is merely H2O, the ocean and all its magnificence isn't lessened by such molecular equations. The trouble isn't with matter or our tendency to ground all properties to it, but rather that we are assuming that matter is one thing when it is completely the opposite of that. Science will undoubtedly expand our previous limits and horizons, but we will inevitably be stuck with our own neural constraints from the very beginning. And herein lays the great human dilemma. The limits of our skull are the limits of our understanding. Yes, we may augment our brains with artificial devices in the future, but even here we will only confront a new limit in time. if we don't know what a single thing ultimately is. Even if we can know various things about a material item, we are circumscribed in our knowledge about comprehending all of its various dimensions and interconnections. Do we even know where we are ultimately? Yes, I may say something such as, I live in Huntington Beach. But that is merely a section in Southern California, which itself is part of a state of 50 in the United States, which is part of a continent that is located on a planet that orbits a sun some 93 million miles away. However, where is that sun? It is but part of a galaxy which is part of a huge Milky Way, which is expanding in a universe of untold size that some 13.7 billion years ago was collapsed into a space tinier than the 14-point size of the Garaman type on this page. Yet, where is that naked singularity located? Does it make any sense to even use such framing questions at this minuscule level? And if some theoretical physicists are correct, then this universe of ours isn't singular at all, but part of a multiverse of unimaginable dimensions. Where are we? Has a simple answer, it appears. We don't know. What this means is that even if we forego religion and spirituality and opt for a purely materialistic understanding of what surrounds us, we are still touching, moment to moment, a mystery that transcends our ability to grasp it. And ironically, the dilemma isn't between matter and spirit, but the persistence of wholly inaccurate and misleading definitions of them. To echo the immortal words of Ludwig Wittgenstein, there isn't a philosophical problem inherent in this supposed dualism, but a confused use of reifications embedded in our languages. Simply put, our use of the term matter is mostly a linguistic confusion, and as such has blinded us from the radical mystery to which it consistently points us towards. The implications here are enormous for spiritual disciplines which wish to be viewed as promoting a scientific outlook. Any meditational discipline that wishes to be seriously taken as a science must ground itself in the very thing it wishes to transcend. But as I wish to make crystal clear, nobody transcends matter as such. Instead, what is transcended are bad definitions. To risk a reframed pun here, there is nothing the matter with matter as a grounding concept, if we first understand that the term itself is under constant evolutionary pressure, in that what it entails changes with more and more study. What this means is that meditational traditions would be much better served if they stopped resisting a purely materialistic explanation of their given inquiries. At first, this may sound heretical or even contradictory, given what the spiritual enterprise presumes. But it is not if we realize that a purely material explanation for inner experiences is precisely what we should expect if we understand science and its definitional aims in a larger purview. Science cannot diminish the spiritual quest if that quest is concerned with truth and not merely dogmatic assertions taken at face value. However, spiritual paths must be open to varying interpretations and must, and this is the kicker that most paths tend to resist, be open to falsification. In other words, for any endeavor to be justifiably regarded as scientific, it must be willing to be corrected, to be changed, to be wrong. While much of spiritual literature advertises itself as scientific, we find that the very basis of almost all scientific endeavors, that of theory-making, is dismissed since it interferes with certain strongly held religious beliefs. For example, when a particular guru instructs the neophyte to go within the laboratory of one's own body to verify the factualness of their respective theology, he doesn't mention that such subjective experiences should be open to varying interpretations of what they could possibly mean. This version of science is more akin to an elaborate food recipe, where the would-be chef needs to follow a set of given instructions in order to know how to make a chocolate cake or a vegetarian pizza. Applied science is successful only after certain facts are well established and known. But at this juncture, any proposed spiritual science is still in its infancy, even if some traditions would like to suggest otherwise. Such versions of science are similar to a computer program like BASIC or Unix, where if you follow just the right set of protocols, you will invariably end up with a repeatable outcome. But this leaves out the most vitally important aspect of science, something which only few meditational teachers seemed to grasp, which is that science isn't a thing, but rather a process of discovery. And along that pathway, there will be false starts, differences of opinion, falsifications, tentative hypotheses, and theories and even facts that are always subject to alteration or even wholesale elimination. For instance, it may be one thing for a religious tradition to say, there is no better method than that of the sound current, which is an ancient and natural science. It was designed by the Creator Himself, is within every one of us, yet whole nations and entire countries of the world are ignorant of it. But it is quite another thing to then claim that such a description is part and parcel of a genuine science. Notice that the preceding quote concerning Shabd Yoga isn't alleging to be merely a scientific endeavor to be placed alongside biology or chemistry, but rather is emphatically stating, quite categorically one might add, to be more fundamental than even physics, since it was created by God Himself as a path back to Him. While a devotee may believe this to be the case, it is fairly obvious to an outsider that this assertion is not a scientific claim as much as a dogmatic one in the guise of scientific dressing. This is important to understand since a genuine scientific endeavor worthy of its name cannot ad hoc cherry-pick which aspect of science they wish to utilize. In cases like this, it is as if science is employed as a form of advertising to reach interested seekers who may have been turned off by more exclusive forms of religious dogmatism. While it appeals to the rational authority of science, it does so by claiming that Shabd Yoga is the highest of all sciences, apparently forgetting in the process that any scientific endeavor worth the appellation must be open to revaluation and correction. Nowhere do we find in most meditational literature a consistent theme of falsification, where past gurus and their ideas are corrected, changed, or overthrown. What we do find, however, is a paradoxical selection of quasi-scientific language, which appears to be offering a potential experimental procedure to validate inner spiritual experiences. But, as we have previously noted, when closely examined, this type of rhetoric is more an instructional formula to achieve an already agreed-upon result, similar to baking a pie, and less a scientific method with all its unforeseen trajectories. Surprisingly, Shabd Yoga, or any meditational discipline that wishes to be viewed as a genuine science, would be best served if, instead of first resorting to dogmatic axioms about its ultimate truth claims, or appealing to unassailable authorities in its lineal past, it looked for ways to falsify itself. A good example of how to do this can be found in Charles Darwin's On the Origin of Species, where in just one sentence he explained how his whole theory of evolution by natural selection could be wrong. Wrote Darwin, "If it could be demonstrated that any complex organ existed which could not possibly have been formed by numerous successive slight modifications, my theory would absolutely break down." Here, Darwin points the pathway by which his whole theory could be turned upside down. Any spiritual endeavor desiring to be taken seriously as a science must do the same.